Hey everyone, here's another example video from section 3.3. Again, it wants us to find the first and second derivatives of this function. So let's start out by saying, we're going to say d of y over d of x of this function, 9x to the fourth over 4 minus 5x plus 7e to the x is going to equal, so the first thing I'm going to do is, again, start with the sum and difference. So sum and difference says if I add two things, I can split that derivative between each thing with an addition sign in the middle. Same thing for the subtraction. So you notice we have a subtraction and we have an addition. We're going to end up being able to split this derivative dy over dx between each of these terms. So I'm going to say that dy over dx of the first part of the function, which is 9x to the fourth over 4, minus dy over dx of the second part of this function, which is 5x, and then I'm going to say plus dy over dx of the third part, which is 7e to the x. And now I'm going to actually find the derivatives of each of those. So I'm going to say dy over dx equals, find the derivative of this first one. I bring the 4 out front. Now I'm going to end up with 4 times 9 over 4. So we'll end up with 4 out front times 9 over 4 x to the third. Okay, you see that we bring the 4 out front, we're taking it times 9 over 4, and then we reduce the power by 1. So we went from x to the fourth down to x to the third. Minus derivative of 5x is just going to be, remember, derivative of x. If you look at what we have right here, which is d of x for just x is going to be 1. So basically, when I take derivative of 5x, I end up with just 5. And then this last part, if we look at what our exponentials are, we have derivative of e to the x is just e to the x. So when we have 7e to the x, this doesn't change. And we know that we can bring, because of this whole product property, so this product property right here, this constants multiplied, notice 3x squared, you can write that as 3d over dx of x squared. So we can actually take this 7, and that could actually be written out front. I don't have a lot of room, so I'm not going to write it out front. But keep in mind, we're just taking the derivative of e to the x, which stays the same. So we end up with just plus 7e to the x. And so then we just have to evaluate this 4 times 9 fourths. And we know 4 times 9 fourths, right? The fourths cancel. And we end up with 9x cubed minus 5 plus 7e to the x. So now they want us to find the second derivative. So we're going to say, let's find the second derivative of y over dx squared is going to equal, and I can start writing that out, or not going to equal, let's say, of this function that we just wrote, which was 9x cubed minus 5 plus 7e to the x. Again, I can split that using the sum and difference. So I'm going to say d derivative of y with respect to x. This is the second derivative of y with respect to x. For 9x cubed, then I can say minus second derivative of 5 plus the second derivative of 7e to the x. And then I can go through and evaluate these just as I did in the first part. So the 3 comes down. 3 times 9 is 27. So we end up with 27x. We go down by 1 power, so that's x squared. Derivative of a constant is just 0. So I'm just going to say plus 0 here. And then the derivative of this, remember we can bring the 7 out front from that rule that we had earlier with the whole constants multiplied. So really I'm just taking the derivative of e to the x, so I just end up with the same thing, plus 7e to the x, which gives you 27x squared plus 7e to the x. So our first derivative is right here, and our second derivative is right here.